4, you have to figure out which formula is represented. So you need to look on your reference sheet, and you're looking for, now there won't be anything with a 47 in it, obviously. That'll be an x or a theta or some variable. But you're looking for a square root, 1 minus cosine over 2. Do you see that? That is the formula for the sine of your angle over 2. So for us, the angle happens to be 47. So this is a formula for the sine of 47. What is that? 23.5, the sine of 23.5? So you're simply looking at what you've been given and you're matching it to something on your page. Now, this one is a little bit tricky. If you look on your sheet, I don't think you see sine squared minus cosine squared. But you see cosine squared minus sine squared. So it's negative. So this is the backwards. This is the backwards of your cosine formula. And it's the formula for the cosine of 2 times an angle. Guys, cosine squared minus sine squared is the cosine of 2 times the angle. So your angle is 87. So this one is negative cosine 174. 2 times 87. And why is it negative? Because we subtracted in the wrong order. Remember we talked about that. That if you do 7 minus 3 and 3 minus 7, they are the same number, but this one is negative. So when you subtract in the wrong order, it's okay, but your answer is negative. Okay, negative cosine. All right, what's this one? 2 tan over 1 minus tan squared. 2 tan over 1 minus tan squared.
Oh, 10.
That is the formula for the tangent of twice the angle. And our angle is 73. So this is the tangent of 146. 2 times 73. So you're matching the equation they gave you with a formula on your sheet. And then you plug in whatever angle you were given. So this is tangent to theta. Theta is 73, so it's the tangent of 2 times 73. All right. We'll practice some more of those. But now we're moving on to solve some more equations. We did these in the first section of the chapter. We haven't done any in a while. But let's see if we can solve this. Alright, here we go. Problem is not solvable when there is a 2x and a 1x. Okay? You can't do it. It's like having P's and Q's, right? You gotta make them all the same in order to solve it. So look on your sheet. What does it say about sine 2x? 2 sine cosine. So I'm going to change this into what it says on my sheet. And now notice that all my variables are x's. Okay, that's good news. That's what you want. So we started with a 2x, don't want it, change it. change it, you have formulas on your sheet to change it. Now, we're ready to solve. Any thoughts? Erica? Go ahead. Shout out. Be brave.
Since we're solving, can we just move the sign to the other side?
That's exactly what we want to do. When in doubt, groupies, get a zero. Get one side to be zero. So she says, since we're solving, can't we move the sign to the other side? Absolutely we can. And now, when they are on the same side, we can factor out a sign. So if we pull out a sign, what are we left with? Two cosine minus 1. Then what? Think about regular algebra. After you have factored, what do? 7 equal to 0. So sine equals 0, or 2 cosine minus 1 equals 0. Now, where does sine equal 0? Now, 0 is a special number. Remember, where do we look when we have zeros? We don't make a triangle, we look on the circle. Because if you try to build a triangle, no side is ever going to be 0. So we need to look on the circle. And we remember that sine is which letter, X or Y? Y. So we look around the circle. All the places we're going to clear around. 0 to 360, so we're all the way around. Where are all the places where the sign or Y is 0? Where's Y 0? Is Y 0 right here? Y is 0. So what angle is that? 0. So X is 0. Is there any other place where sine or Y is 0?
For sure.
And that's it. Now you can say, what about 360? But we're not going to count 360 because it's the same as 0 and we already wrote it down. All right. Now this one, we're going to add 1 and divide by 2. So I did that all in one step. I hope that's okay. I added 1 and divided by 2. It says the cosine is 1/2. Alright, so I need a triangle that looks like this. How do I know it looks like that? Because cosine is adjacent over hypotenuse, x over r. Well, do you recognize that triangle?
100% I do.
This angle right here is how big?
60.
60. So one of your answers here is 60. Now, use your head. Cosine is x.
It's gonna be 120.
No. What quadrant do I need to be in? If it's going to be a positive number, I got to be in quadrant 4.
So
That's where x is positive. That's where x is positive. Cosine x. So that's still a 60. What's this angle right here? 300. So there are the answers to the problem. Now, nothing there was hard, but there's a lot.
Like I said, you just do one whole set, because we want to split off the X is 0 to 86.
Oh no, you can write all of it. All right, let's try the next one. This one looks very, very similar. Would you agree that the problem's not solvable? cannot solve it because it has a 2x and an x. So we're going to get rid of that 2x. So we're going to look at our sheet. And this one, let me see if I wrote them all out. Yeah, this one is a little bit different because there are actually 3 different formulas that you can use for cosine 2x. Do you see that? So now you need to pick the one. Any of them will work, but one of them is going to be easier than the others. Can you look at the list, look at the problem, and tell me which one you think might be the easiest to use?
Third one?
Which version?
2 cosine. 2 cosine.
Exactly. 2 cosine squared minus 1. Now, first of all, that is one of your cosine 2x formulas. Understand that any of them will work. Any of them will work. Why is this one going to make it easier for me? It's the only one with just cosine. Since we have a cosine already in the problem, it's easier to use the formula that has cosines because now my whole problem is cosines. If I use one of the other ones, I gotta mess around figuring out how to mix the sines and cosines. Doable, definitely doable because it's so much easier. All right, thoughts? What about next? Subtract the cosine. And when I subtract it, I'm going to put it right in the middle. Because I'm recognizing that I have an equation with a squared, a regular, and a number. So this is exactly like having something like this. Do you see that? Do you see how it correlates? Now, what would you do with that? If you had to solve that, what would you do? You'd factor it, right? And what would the factors be? 2m and m plus 1 minus 1. Does that check out? I think it does, yeah. So how is this one going to factor? This will factor the same way, only instead of m's, I have cosines. So 2 cosines plus 1 and cosine minus 1. You gotta make that connection. That this is really a quadratic equation. This is quadratic. So you're going to solve it just like you solve a quadratic equation. All right, so what's cosine equal? Cosine either equals negative 1/2, remember I'm setting it equal to 0, or cosine equals 1. Well, I erased my circle and I shouldn't have. This time, as I look around my circle, I am looking for where the cosine is 1. Where does that happen? 0 right there. Right? That's the only place cosine is 1. Remember, cosine is your x coordinate. So this one has an answer of 0. And that's it. Because there's no more places that have an x of 1. Okay? Now, I want cosine to be negative 1/2. Won't that be here or here? And if cosine is 1/2, that's a √3. Isn't this a 60 again?
Yeah.
But it's the 60s in quadrant 2 and 3. So what is your idea about the next one? Look at the problem. What is gonna be the very first thing you have to do?
Change the.
You could subtract over the cosine 2x, but first, I think I would do something else.
Change the.
Can I do a 2x? No, so I gotta change my 2x. And again, some of them you don't have a choice. This one you have a choice. So which version do you think we should use? Look at your whole problem, Brandon. Two cosine squared minus 1. Does that make sense? This problem is full of cosines, right? So why would we want to introduce signs if we don't have to? We don't have to, so I wouldn't do that. Now, Brayden, I'm going to get everything on one side, okay? But I think I'm going to go that way. I'm going to get my 0 over here. So I'm going to subtract cosine squared. And that's going to be just 1 cosine squared. I'm going to subtract cosine. Everybody on board so far? Okay. Where do I go from here? Factoring. I would love the factoring. That's a factor. Think about it for a minute. This would be m squared minus m minus 1 in quadratic, irregular equation form. Is that going to factor? I don't think it does. Oh, as my mother would say, shooty tooty. What do we do if it doesn't factor? We use the quadratic formula. So we are going to take this equation right here, and we're going to solve it with the quadratic formula. Now, before we start, what is my A?
Cos squared.
No. A. A is 1. What is my B? Negative 1. And what is my C? Right? Okay. All right, so here we go. Our variable is cosine x. So we are solving for cosine x. In a regular one like this, we would say m equals negative b, da, da, da. Well, our variable is cosine. So cosine x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So cosine x equals 1 plus or minus the square root of 5 over 2. So I'm going to separate that, and I'm going to have two sets of answers. Cosine is 1 plus root 5 over 2, or cosine is 1 minus root 5 over 2. Now we definitely need a calculator, because if we're going to do it by hand, it has to be like 1/2 and root 3 over 2. This is not, I don't know what these are. So I'm going to get a calculator out. I'm going to do this one first. want to remember how, if the cosine is this ugly number right here, how do I find the angle? What do I have to press on my calculator to find the angle? Oh, Paul, you need to know this. Second cosine, thank you. So I'm gonna do second cosine, 1 plus root 5 over 2. Now, be really, really careful. This can be tough to type in. So go ahead and type in how you think it will be, and then I'm gonna type it in and we're gonna check. If you didn't get the right answer, I'm gonna give you a suggestion. But you guys might be able to type that in relatively easily with your newer calculators. It is a pain in the butt with the old ones. Oh. You had an error. You're right, there are no answers. That's not a solvable. That one's not solvable. So if you got an answer, you did it wrong. But if it said error, you got it right. There is no answer to that.
So there,
Now we're gonna try the other one. No, there's no answer. That's not a solvable equation. So let's see if this one is. Now we're gonna see if this one is solvable. This one gave me no answers. We'll talk about why. But this one is not solvable. This one is. Did anybody get an answer to this one? Type this in. Did you get an answer?
128.17.
128.173. Make sure. Yep, that's exactly what I got.
I don't know how you type that in.
Now, one way to type it in. If you try to type it in like this, there are going to be quite a few parentheses on an older calculator. When I type these in, I type literally, type with me, 1 minus the square root of 5 equals, divided by 2 equals, and then second cosine, second answer. Use your answer button. And that should give you the right answer.
Mine was it.
It can't be going to be.
Second.
No, go do it divided by 2.
No, this is gonna work. You have to hold calculator, so do what I said. You do 1 minus the square root of 5 equals, and divide that by 2.
I'm doing. Where's the new
Then
calculator?
second cosine, second answer.
Which is the new calculator, Mike?
Which is the old calculation?
If you have an old calculator,
You go.
you'll automatically get these parentheses, but then you need this one, then you need that one, and then that one. So you would need to type all those parentheses on an old calculator, which is fine, I just don't wanna do that. So I type in the fraction itself, and then second cosine that decimal that I get. So I don't have all those parentheses. You guys, these calculators build, they work better when you don't throw them around. If they don't build the fractions for you, it's harder. If they do, it's easier. All right, let me wrap this up though here, and then we'll talk about your calculator issues, but let's finish this. We're not done. This answer was over here in the second quadrant. It was 128.173. Would you agree with that?
Yeah.
And that makes sense because this number is a negative number and cosine is negative over here in this quadrant. Right? That makes perfectly good sense. But cosine is negative somewhere else. Where else is cosine negative?
3.
Quadrant 3. So now, we need to figure out this answer. The calculator will always give us the smallest one, so it gave us the 128. But now we have to figure out the bigger one, just like we have done in the other problems we did. Okay, any idea how we might do that?
180 minus 128.
Oh, let's talk about that. So 180 minus that. So what Blake is doing is finding out that this little angle right here is 51.83,
Yeah.
right? Now guys, doesn't that mean this one is also 51.83?
Yeah.
This one right here?
180 plus.
So now I'll do 180 plus and get 231.83. 827.
Doing pretty simple.
So a little problem solving involved there. That is a crazy hard problem. I'm not gonna put that on a test or a quiz, but we just worked through it. How come this didn't work? Well, if you type in that fraction, 1 plus the square root of 5 divided by 2, this decimal is like 1.618, okay? So what that says is the cosine is 1.618 over 1. So if you tried to draw that triangle, it would look like this. Is that possible? No. In fact, sine and cosine cannot be bigger than 1. Sine and cosine must be less. Remember the graphs? How high did they go? Up to 1, down to -1?
If my calculator was in radians, would I get a different answer?
You'll get a different answer. It can be a correct answer, but it would be the radian answer. Yep. Yep. So you won't be getting numbers like this, you'll be getting decimals. All right, let's try a couple more. Speaking of radians, number 4, A and B are both radian problems. How do I know that problem 4 is in radians? You guys, oh my goodness, look at the directions for problem 4. These oh, I erased them, but these directions were 0 to 360. That's degrees. 0 to 2 pi is radians. Nothing changes, except you gotta be in radian mode. And like over here when we were subtracting and adding 180, we won't be subtracting and adding 180, we'll be adding and subtracting pi. But the math is going to stay the same. So, take a look at this equation. It's already set equal to 0, so that is good news. So what am I gonna do? I've done it, this will be the 3rd time I've done it.
So we factor.
No, that doesn't factor.
Two cos,
Because it's cos squared plus cos, not cos squared plus cos squared. It'd have to be 2 cos squared plus
That's not really squared,
It's
that's
not
a
squared
2x.
at all, so you're wrong.
What's your grade?
But
Right
it's
under
kind
F.
of right.
So you change that.
They're not, they don't match. So, you guys, if they don't match, there's nothing you can do to make them match except change it. So what are you gonna do with cosine 2x?
2 cosine.
2 cosine squared minus 1?
You can factor that.
Let's get that in the right order. 2 cosine squared plus cosine minus 1. And then I heard somebody say you can factor that. I don't want to confuse you even more, but remember, you can rewrite that with a different variable. So like 2m squared plus m minus 1. So instead of having cosine as your variable, make it a letter. I use m, you can use a, or whatever you want.
I just like X.
I use x
X
over here.
is the most like, yeah.
I use Q.
But that x would
I
be
use
different
big-
than this x.
There's X for sure.
So how's it gonna factor?
I use H for.
2
2 cosine and cosine.
Yeah.
I need a 1 and a 1, and one of them has to be negative.
The first one.
That's right. Because that gives me positive 2 and negative 1, so that's exactly what we want. Yep. All right, so what's it say? It says cosine equals 1/2, or cosine equals negative 1. I keep erasing my circle, and I should leave it up here.
How is that?
What's the matter? Foil it. If you foil it, you get this.
How? If you put -1 and cosine, how is that possible?
2 cosine squared.
Yep.
Plus 2 cosine minus cosine. Positive 2 minus 1 is 1. And negative 1 times 1 is negative 1. Okay? Now, where is cosine negative 1? Well, 180, but we're in radians, so we'll say pi. It is 180, that is absolutely correct, that's the right spot. But since we're supposed to be answering in radians, we won't say 180, we'll say pi. That is the only place where the sine is, where the cosine is -1. Now, where is the cosine 1/2? Well, you already told me earlier that that's 60 degrees. But I'm in radians. So 60 is a 1/3, that's right, this is pi over 3. Very good, pi over 3. No, it's not hard to figure out, but he figured it out and the rest of you did, so good job, boys.
You like looking at 300?
And 300 would be the other one. Now, when you got 300, you took 360 minus 60. If I'm in radians, I'm going to take 2 pi minus pi over 3. So all the way
5
around
pi over 6.
is, so all the way around is 6/3. So I'm going all the way around except for the last third. So that's 5 pi over 3. Nothing different about that problem and the ones we did before, except the way we write our answer. Okay, we're gonna do one more, and then we're gonna go to the homework for a minute. So we're gonna do one more, so here we go, last one. Sine 2x equals 2 sine x.
But I did.
It doesn't matter, we can figure it out, we're good.
Okay, so first of all, it's like a big red flag. See that 2x? Can't be there. So what are we gonna do with sine 2x?
Two
Two
signs.
sine cosine. You do not have a choice. You do not have a choice. Two sine cosine, that's what it is. I want you to always go back to what Erica said earlier. What was her suggestion earlier? Get it set equal to 0. I know some of you are gonna want to divide. You can't. You have to get your equation set equal to 0. Okay? So we're gonna get it set equal to 0. I can never tell if you people are listening or not. I hope you were listening when I said you can't divide. We're not doing that. It doesn't work. You can't do it. If you divide, you lose answers. Now what do? Take out a 2 sign? Might as well pull out the 2 sign. You can't delete them. We're gonna factor them out.
Just a question.
Think about that for a minute. If I just don't want something, do I just delete it? No. Not in math class. Alright, if I take out a 2 sign, I'm gonna be left with cosine minus 1. Would you agree?
Yeah.
Now I set them equal to 0. So sine equals 0. Now kids, don't freak out about the 2. If you divide by 2, don't you get sine equals 0? Yeah, the 2 doesn't really play into it. Or cosine
No, you can't
equals
divide by
1?
0. You can divide 0 by things.
Yeah.
Cause that'd be right.
Yes, good.
Yeah, that's what.
So, we're here and here. This is what we got. So I'm gonna go to my circle for the umpteenth time. I'm gonna look around. And what am I looking
2
for?
5 1 3.
I'm looking for where the sine, which is y, is 0. So here we go, all the way around. Where is sine 0?
0.
At 0 and pi? That okay? And then where is the cosine 1?
0.
At 0, right there. So I don't even need to write it down because I already wrote down that answer. So this one is just 0 and pi for our answers. Perfect, is right. All right, now I want you to get your homework out.
5-4 homework.
Yeah. 5.4 homework.
We do the,
And I want to work through the first couple with you to make sure we're getting the hang of this. So, number 1, this is going to be assigned tomorrow because we're going to finish it tomorrow. Okay? This will be assigned tomorrow. But I'm going to do the first couple with you. So, number 1 says, find the sine of 15, and the word exact tells you I'm not using the calculator.
45 minus
It says find the exact value of 15 using the half angle. Now, Eli said we could do the sine of 45 minus 30. He is right. That will be the sine of 15, but the problem is, that is my u minus v formula. Those are called the sum and difference identities, because you're adding and subtracting. This specifically says, do a half.
Oh,
So what is
30 divided by
15?
That's my bad.
Half of 30. So we're doing the sine of 30 over 2. I need everyone to understand this is perfectly okay, but it doesn't follow the directions. This will work. This will give you an answer. But I need to do it this way for the directions. Okay? So now I look at my sheet. It's the sine of an angle over 2. So what does my sheet say that formula is?
Plus minus.
Plus or minus the square root of
1 minus cosine 30.
1 minus cosine of the angle, so that'll be cosine 30. This is your angle now in the
Over
formula. And it's all over 2, that's exactly right.
Use that right.
Where'd you find it?
Okay, so now I'm gonna find out what is the cosine of 30. So here's 30. Triangle looks like this. Right? Which, by the way, if you need to add that to your reference sheet, you can. I think we already talked about that, but, so what is the cosine of 30? Root 3 over 2. So I have 1 minus root 3 over 2 over 2, and that whole thing is under a radical.
We're at times by 2.
We're gonna multiply everything by 2. And when we do that, we're gonna end up with 2 minus root 3 over 4. All that now is under the radical. I don't know why that's a negative. 2 minus root 3 over 4, all under the radical. With me? So I'm taking the square root of the top, and that is just gonna be the square root of 2 minus root 3. Okay, I can't do anything with that. But the bottom is the square root of 4, which is 2. And then the last thing I have to do is figure out, should this be a positive or a negative? Now think about what you're doing. You're finding the sine of 15. Where's 15? If you just drew 15 degrees, where would it be? It would be quadrant 1, and in quadrant 1, everything is positive. If this were the sine of like 200, then it would be negative, because you'd be in quadrant 3. But it's the sine of 15, so I want the positive root. All right, manageable? Yes. Now, 2. Problem 2, this is the kind where you match up what's on your formula sheet with the problem that you have. So you have 1 minus 2 sine squared. So find it. On your sheet, there should be something that's 1 minus 2 sine squared.
So it's cos 2.
It's a cosine of twice the angle. Right? And our angle is 53. So this is the cosine of 106. It's a double angle cosine, so you double the angle. All right, what's this one? 1 minus cosine 13 over 2. We just used that one, right? This is the formula for the sine of the half angle. And the angle is 13. So this is a formula for the sine of 6.5. See how easy this is, guys? It's pretty easy. All right, except for C now. C's another one of the tricky ones. What's wrong with C? I heard somebody say it. It's flipped. Isn't it backwards?
Yeah. It's gonna be negative.
Alright, so figure out which formula it is first of all, and then it's gonna be negative, that formula.
72.
So this is what?
Negative
Not sine.
cosine.
I mean cosine. This is a cosine formula.
72.
Cosine squared minus sine squared is a cosine formula, and it's the cosine of 2 times it. So this is negative cosine 72.
So that's just.
This is
Just try to
backwards.
trick you.
When it's subtracted in the wrong order, go ahead and use your formula, but you gotta make it negative. Okay? Alright, I'm gonna stop there. And you've got 4 minutes to
Do we go?
do something, no, to do something productive.
Something like that. 4 minutes to take off.